Okay, good morning, Professor David J. Okay, my next topic for this morning on college algebra, long form video format discussion, college algebra. This will now be lesson number 52. The subject matter is I will be presenting example problems on the topic arithmetic sequence and series. Okay, let's proceed. This will be college algebra, lesson number 52. The title of the topic will be Example Problems Involving Arithmetic Sequence and Series. There is a difference between sequence and series. A sequence is just uh, numbers which follow each other but without the addition or subtraction. For a series, it will be numbers which are following each other and they are actually in between them are actually the plus or minus uh, sign of what you call these operations. Okay, let's proceed. Example problem number one for the evaluation of arithmetic sequence and series. Okay. Example number one, evaluate the sum. Okay, the sigma notation, the summation. Okay, with the limit from 0 to 12 of the given expression k over k plus 1. We are to expand this one by using the sigma notation. Okay, the limit is just from k equal to 1 to k is equal to 12. This is just a direct substitution one. If you do not know how to, what you call this, expand this one under the topic arithmetic series and sequence, okay? Okay, you will be missing that problem under the SAT maybe. Because they might give you one problem under this, and if you don't know how to simplify this one, okay, you lose 1 point. Okay, number one, solution of this. The summation with the limit from 1 to 12 of the given expression k over k plus 1, the meaning of this, for every k, we will start with 1, we will substitute the value. That's the meaning of this. Okay? For every value of k from 1 to 12, we will substitute this k here to this given expression, then we try to simplify. So this is just a direct substitution solution. So if we try to follow this expression here, then we will start with the value k equal to 1. When k is equal to 1, they should be 1 plus 1 plus 1. So the first term will be 1 over 1 plus 1. Okay, this is k, this is k. Next value of k will be 2, right? So this will be 2 over 2 plus 1. Next value of k will be 3. So this is 3 over 3 plus 1. Next value of k will be 4 over 4 plus 1. Next value of k will be 5 over 5 plus 1. We are following this expression here. Next value of k will be 6 over 6 plus 1. Next value of k will be 7 over 7 plus 1. We are following the expression. Next value of k will be 8 over 8 plus 1 plus next value will be 9. This is over 9 plus 1. Next value will be 10 over 10 plus 1. Next value will be 11 over 11 plus 1. And the last value, because the upper limit is 12, so the last value will be 12 over 12 plus 1. So actually how many terms? It should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 terms, right? So if we try to simplify, first one will be 1/2. 1 over 1 plus 1, that's 1/2. Next one will be 2/3. Next one will be 3/4. Next one will be 4/5. Next one will be 5/6. Next one will be 6 over 7. Next one will be 7 over 8. Next one will be 8 over 9. Next one will be 9 over 10. Next one will be 10 over 11. Okay. Next one will be 11 over 12. And the last one will be 12 over 13. So the lower limit is 1 and the upper limit is 12. Oh, that's the meaning of this. We are to substitute k starting with 1 up to 12 using this expression here. That's the meaning of this, the so-called sigma notation. So if we try to calculate this one, of course, these are fractions with different denominators, and to compress this one, it's a very hard thing. How many terms? 12, right? So if you got your calculator, you start with this, 0.5 plus 2 over 3, then so on, up to the value 12 over 13. I operated this one using the calculator, the approximate value of the summation of the given expression k over k plus 1 with the limit from 1 to 12. The summation is 9.819. That will be the answer. Okay. It's hard to simplify this one because the denominators are different and there are 12. Actually, we could do it, but it will take a long time, right? But if you want the answer in terms of decimal, the answer will be 9.819. Okay, that's it. Example number 2. Rewrite the sum using the sigma notation. We are given the, okay, I want to emphasize this one. This one here is a series, right? Arithmetic series. Because there is a plus sign in between them, right? For it to be sequence, it will be something like this. This one is a sequence. That's why this sequence. Okay, this is a sequence. Okay, so at least we now know the difference of a series and a sequence, right? If the numbers actually are preceded by a plus sign in between them, it should be a series. But if it's only like this, 7, 4, 1, it will be a sequence. Okay, so at least we know the difference between a sequence and a series. For the next example, rewrite the sum using the sigma notation. The given series is actually 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square. The problem is asking what will be the sigma notation of this. Okay, you could represent the variables here to be x equal to up to, and what will be the required expression. Okay, so it seems we are solving the problem in reverse, right? We are given the expansion and we want to compress this one as a sigma notation. Let's try to, what they call this, observe the value on the denominator. The one inside the quantity. The first value is 1, right? The second value is 2. The third value is 3. If we try to take the difference of 2 minus 1, okay, the difference is 1, right? Right? And the difference of 3 minus 2, it's also 1. So the numbers under the denominator is under arithmetic sequence. Okay? But this whole term here is a series, but the terms under the denominator without the square are in arithmetic sequence. And the difference is actually, because I place it here, the excess is in an arithmetic sequence. So if we try to bring out the compressed equivalent of this one, okay, it should be the summation. Okay, I will represent the variable to be x with the limit from 1 to 4. The given expression should be, you can observe it. This is 1 over 1 square, 1 over 2 square. So we just represent this by x. We just represent this by x. So the first one, the one inside, it's also x. So the resulting required expression should be the expression, the summation with the limit from 1 to 4 of the expression 1 over x squared. Or this will be the answer. Right? Because if we try to expand this one, let's try to expand this. We will try to see if it comes out as the original problem. If we try to expand this, it will be 1 over 1 squared. The first value of x will be 1, right? Plus 1 over the next value will be 2, right? 2 squared. And the next value will be 3, right? 1 over 3 squared. And the last value will be 4. This is 1 over 4 squared. And if we try to simplify this one here is actually the given problem. So the correct sigma notation, sigma notation of this expansion here, it will be the summation of the expression 1 over x squared with the limit from 1 to 4. Okay, that's the answer. This expansion here, if we try to compress it into a sigma notation, it will be the summation of the given expression 1 over x squared with the limit from 1 to 4. Okay, the initial value will be 1, no, the one underneath, and the last value will be 4. This is 4, this is 1. Okay, that's the proper way on how to bring out an expansion, converting it to a so-called sigma notation. It should be by observation, right? Example number 3. This will now be an arithmetic sequence. Okay? In between the numbers, there is no plus sign or minus sign, right? It's just a comma, right? So the problem here is find the 17th term of the arithmetic sequence 7, 4, 1, right? If you try to observe it, this is the first term, this is the second term. The problem is just asking for the 17th term. So actually, 7, 4, right? Minus 3, minus 3. This is minus 3 again. Okay? So the fourth term is actually minus 3, right? Or minus 2. Okay? But the problem is asking what will be the 17th term. It should be a negative value because the sequence is actually decreasing, right? The sequence 7 for 1 is in the so-called descending order. So if we are to look for the 17th term, the value of the 17th term will be a negative value. So by using the equation under arithmetic series, e sub n or sequence, e sub n is equal to e sub 1 plus the quantity n minus 1 times d. Okay? We are looking for this on here, e sub n. The value of n should be 17. A1 is 7. The common difference will be second term minus first term. So this should be 4 minus 7, it is minus 3. If we try to check it, if it's really minus 3, 1 minus 4, it's also minus 3. So the common difference as it descends, okay, it is actually minus 3. So the value of d here is minus 3. So the 17th term now, by using this formula, 17, a with the subscript 17, meaning the 17th term, should be equal to a1, 7, right? Plus the difference 17 minus 1, this is 17 minus 1. And the value d, the difference is a negative value, right? Because it is in the so-called descending order. This is minus 3. So this is 7, 16 times minus 3 will be minus 48. So the 17th term will be negative 41. That will be the answer. As you can see it, it is in the so-called descending order, right? 7, 4, 1, minus 2, right? Then minus 5. And the problem is asking what will be the 17th term. You can check this one by solving it manually or by using this formula. We shall be using the formula, okay, that's why we are studying algebra, right? So the 17th term for this problem will be negative 41. last example. Find the sum of the first 20 terms of the arithmetic series. This is a series now. This is an arithmetic series. Okay? There are plus in between. Right? So it should be a series. It's not a sequence. Right? So find the sum of the first 20 terms of the arithmetic series. 5 plus 8 plus 11 plus 14. Right? There is a formula on how to take the sum, and the summation of an arithmetic series, capital letter S with the subscript n, when the sum of an n terms for arithmetic series will be n over 2 times open bracket 2a1 plus n minus 1 multiplied by d. We derived this one from lesson number 51. So this is now just a direct substitution one. N will be 28, A1 will be 5, right? N minus 1 should be 28 minus 1, it will be 27. And the common difference, it should be 8 minus 5, which is 3, or it could be 11 minus 8, which is also 3, or it could be 14 minus 11, which is also 3. So we trick the validity of the common difference, it's really 3, right? So all the variables on the right hand side are all given now. So this is just a direct substitution now. So the sum of the 20 terms of the given arithmetic series should be n over 2, 22 over 2 times open bracket 2a1, 2 times 5, plus n minus 1 is 27. The common difference is 3, positive 3. It's going up. It's ascending order, right? So this is times 3. Okay, simplifying this one, this should be 14. 14. 10 plus 27 times 3 is 81. 10 plus 81 will be 91 times 14, that will be 1,274. So the summation of the terms of the given arithmetic series, okay, which is 5 plus 8 plus 11 plus 14, the sum of the 20 terms is 1,274. That's it. As simple as that one. Okay, so we now know what's a series and what is a sequence. The last time around, we got the n term for an arithmetic series, and we got the sum of the n terms of an arithmetic series. And these are given by the examples, this one here and this one. For the first two, it will be the sigma notation, the summation of sigma notation. And the last one is actually the compressing of an expansion to a sigma notation. Okay, that's it, guys. Good morning from Los Angeles. This is Professor David J. Delos Reyes.